Hello, this is Ms. DB. In this video, we are going to look at special systems of linear equations. We did look at this at the towards the end of the graphing systems assignment, and you saw that often when you graph two lines, they will intersect at one point, and that will be the one solution. But sometimes when you graph a pair of lines, they are parallel to each other. Those lines will never cross. There will be no solution. We call this inconsistent. And the third thing that can happen is you can graph two lines and they end up being the exact same line on top of each other. When that happens, there are infinitely many solutions. All of the points on this shared line would be solutions because they would all be on both lines. This is called a dependent system. So here's another way of thinking about it. We have a consistent system when you have intersecting lines and there will be one solution. In that kind of a system, there will be both slopes will be different, and the y-intercept can either be the same or different. When you solve with algebra, you'll actually find answers for x and answers for y. This is what we did when we did the solve systems with algebra worksheet. When you solved with substitution or elimination, all of your answers should have been in this kind of format. You should have got intersecting lines for each of them. Sometimes you will get the same line on top of each other. So that is called dependent solutions. If you're going to just name these with one word, we would call this dependent, and we would call this consistent. Or consistent independent is the other word. There are infinitely many solutions. Note that this is not the same as all real numbers, because like this is not a solution over there. It's only the points that are shared on the line. They have the same slope. They have the same y-intercept. So if you wrote these both in slope-intercept form, the m and the b would be the exact same thing. Now, usually when you're given them, they're not in slope-intercept form yet. But if you rewrite them in that form, you'll be able to compare the slopes and the y-intercepts and see what you get. If you're solving with algebra, you would get a true statement. Like the x's would cancel out, the y's would cancel out, and you just have two numbers equal to each other, and it would be true. For an inconsistent system, that's when you have parallel lines. There will be no solution, and that's what you would write for an answer if you were solving this. They have the same slope. If you wrote these both of these equations in slope-intercept form, you would find that they have the same slope but different y-intercepts. And if you're solving with algebra, the x's will cancel at some point, or the y's, and you will end up with a false statement when you're done. That's how you know it would be inconsistent and no solution. All right, so we are going to go ahead, and for the first problems, we are going to use this column. We are going to write them in slope-intercept form, and we're going to compare the slopes and the y-intercepts so that we can tell, even without solving, what kind of a system we would have and how many answers we would have. So in number 1, the second one is already solved in slope-intercept form. We can see that m is equal to -3 and that the y-intercept would be -7. Because remember, y equals mx plus b is slope-intercept form. However, the first equation is not yet in slope-intercept form. So we need to solve this for y in order to get it in the right form. So to solve this for y, we first will get rid of what's being added or subtracted, which is that 3x is being added. So we would now have minus 4y, or a negative 4y, is equal to 13 minus 3x. But instead of writing 13 minus 3x, I know that slope-intercept form always puts the x term first, so I'm going to write negative 3x plus 13. So why did I put a plus 13? Because this is a positive 13, so I could put a plus sign there if I needed it, and that plus sign then that positive sign becomes the plus sign. So negative 3x plus 13. Now I need to solve this for y, so I would need to divide every term by -4. And it's okay that we have fractions, that's okay. So we have y equals -3x over -4. A negative divided by a negative is positive. So this would be simpler to write 3/4 x And then this, it doesn't matter if you put negative 13/4 or if you leave the negative on the bottom, that doesn't really matter. So my slope is 3/4 and my y-intercept is negative 13/4. Now what we're going to do is decide whether this is going to have one solution, if this is a consistent independent system with different slopes and either the same or different y-intercepts, or if they have the same slope, then it's one of these two cases. But because one of my slopes is -3 and one is 3/4, I have different slopes. So I am going to have one solution. These two equations will cross at one point. They will have one solution, and they are a consistent independent system. Consistent independent system. And you'll do the same thing for each of these. So the first step is to solve for y, and some of them that part's already done for one of the equations, and in other ones you have to solve for y first. Let's solve number 2. So we have 35x plus y equals 3. That's not supposed to be a point, it's just 35. And then I'll worry about the other one in a minute. So to solve this for y, it's going to be quite quick. I just need to subtract 35x from both sides. So then I would have y equals negative 35x plus 3. For the second equation, I have 1.2x plus 2y equals 6. So I would start by subtracting both 1.2 from 1.2x, x from both sides. So that leaves me with negative 1.2x plus 6. And then I'm going to divide everything by 2. So you can probably tell pretty quickly that we're not going to have the same slope, because this one is negative 0.6 and the other one is negative 35. Those are not the same. So again, these are going to be, there's going to be one solution. These are going to be a consistent independent system. I kind of hope to show you one that would have something different. How about, well, I'll let you work on it some more. Oh, let's look at 7. I think 7 will work out. So at 7, we almost have the bottom one as the right form. If I just wrote it in the opposite order, I can see that the slope of this is negative 3 and the y-intercept is 5. Okay, let's do the top one. 3x plus y equals 4. Subtract 3x from both sides. And we get y equals negative 3x plus 4. So the slope is negative 3. The y-intercept is different, but the slopes are exactly the same. So that means when you have the same slope but different y-intercepts, you have this inconsistent system. You have parallel lines that will never intersect, and there is no solution. So that's what you'll write for this one, that there is no solution, parallel lines, they'll never intersect. Write some of that down. All right, then on the next section, it says find the solutions of each system of equations using, you can use either substitution or elimination, whichever one you feel more comfortable using, or whichever one this system is set up for. And then if you don't get an answer, then you'll say what it is, whether it's inconsistent or dependent. But on a lot of these, you will get an answer. These are not all going to be no solution or infinitely many solutions. So this one is set up for elimination. Remember elimination? We have a plus 2y and a plus 2y. Oh, it's almost set up. It's not quite. Let's multiply everything on the bottom by negative 1. That way, I would have negative 1 times negative 2x. That's a positive 2x. Then I'd have negative 1 times 2y is minus 2y. And then don't forget to do the other side. 24 times negative 1 is minus 24. And the top equation I'm not going to change. I'm just going to rewrite it. Now look what we have. We have right here plus 2y minus 2y. The y term cancels. And you're going to be able to find the value of x rather quickly. So you're going to finish, you're going to find x, and then you're going to find y. So you're going to be able to get a solution for this. These are two lines that cross at one point. If you can find one variable, you can find the other, and it will have a solution. Let's look at number 11. This one is set up for substitution. We have y is equal to negative 3x minus 7. That's what y is equal to. So in the top equation, wherever I see a y, I can replace it with negative 3x minus 7. So you start writing the top equation, 3x minus 4. When I come to the y, I stop, put a parentheses, and then replace y with what it is equal to, which is negative 3x minus 7. Then I finish writing the top equation. All I have left is the equals 13. So you're going to solve this equation for x and see what x is equal to. So the 3x just gets written down again, and now we have to do the distributive property here and here. So we have negative 4 times negative 3x, which is 12x, and then we have negative 4 times negative 7, which is plus 28. Tornado siren is going off. Okay, so the tornado siren is over. So now we would finish solving this equation to find x, and then once you find x, don't forget to also find what y is equal to, and that's how you'll finish that one up. So this one will also have one solution, and you will be able to find it. Let's see, how about let's start number 12. Number 12 says 5x minus 4y equals 1, and negative 10x plus 8y equals negative 30. Now you get to pick if you want to use substitution or elimination. You could probably use elimination with this one fairly easily. You could divide everything on the second equation by 2, or you could multiply everything in the top by 2. I guess I'll go ahead and multiply everything in the top by 2. And I'm doing that so that I can get my y terms to cancel. Because if I multiply everything by 2, I'd have negative 8y and a plus 8y. So everything on the top by 2 gives me 10x, and then I would have 2 times negative 4y is negative 8y, and then on the other side 2 times 1 is 2. And then I'm just going to rewrite the bottom equation below it. Negative 10x plus 8y equals negative 30. This is very interesting. Look what happens. We have 10x minus 10x. Well, that cancels. I have negative 8y plus 8y. That also cancels. I don't have anything left on the left, so I write a 0. You can't just leave it hanging. And then on the right side, I have 2 minus 30 is negative 28. So when this happens, when you're left with no variables, look at whether you have a true statement or a false statement. This is clearly false. Let's look back at the table. If we end up with a false statement, it's this false statement. That means that the lines were parallel and that they had the same slope and different y-intercept, that it's inconsistent, and that there is no solution. So this is inconsistent, this one we just solved, number 12. So we will write inconsistent. And I'll also write that there is no solution. And there's a few more to solve. And remember that if you have, like number 15, if you don't want to work with fractions, all you need to do is multiply both sides of the equation by a number that would clear the fractions. For example, in this problem, I could just multiply both sides by 2. If I multiply both sides by 2, I do the distributive property. I'd have 2 times x. Then I have 2 times negative 1/2. What is a half of 2? Half of 2 is 1. And we have a negative because it was a negative there. So this would be negative 1y or negative y. And then on the other side, we have 3/2 times 2. 3/2 times 2. And the 2's cancel, and I'm left with just 3. So we have 2x minus y equals 3. And then you can solve, this will be then set up for elimination because the other equation is 3x plus y equals 6. So you can add these together and solve and find your answer. Let me just start this a little bit, go a little farther with this because I think you might get a fraction. So we add these together, you get 5x equals 9. Yeah, so you get x equals 9/5 is going to be your answer when you divide both sides by 5. If you don't want to work with a fraction plugging back in, then you could change this to a decimal, but it's not like the easiest one to recognize in the world. It'd be 1.8. Because you still have to find y. At least the equation is quite easy if you use this one. 3x plus y equals 6. You're going to be able to solve for y pretty quick. So you're not going to have to do a lot of computation with your fraction or your decimal. All right, for 16 through 20, you only have to do 2 of these problems. So you're going to write the equations and solve, like we just did on the solve systems with algebra. And then explain your answers, show your work. I'm just going to start out let's look at number 18. It says Jamal placed 2 orders with an internet clothing store. The first order was for 13 ties and 4 pairs of suspenders. So I'm going to use T for ties. My S's look like 5s, but I'll try to use S for suspenders, and I'll try not to look like 5s. And that's his total. The second order was for 6 ties and 2 pairs of suspenders and totals this much. The bill does not list the per item price, but all the ties have the same price and all the suspenders have the same price. What is the cost of 1 tie and 1 pair of suspenders? So we need to know the value of T and the value of S. So for the first store, we had 13 ties and 4 suspenders. So you would write that, and it was equal to 487. And in the second one, it was 6 ties and 2 pairs of suspenders, and the total was 232. So you have here a system of equations, and you can solve this with either substitution or elimination. I'm just going to give myself a little more room here, but not like that. There we go. Ignore these. Okay, so let's see. You can either solve this with substitution or elimination. I think that I'm going to solve with substitution. I'm going to solve the second equation for S. So to solve this for S, I would start by subtracting 6t from both sides. So I'd have 2s equals 232 minus 6t, and then I have to divide every term by 2 to get s by itself. Because they're all even numbers, this isn't going to be too hard. 232 divided by 2 is 116, minus 6 divided by 2 is 3. So this is what s is equal to, 116 minus 3t. So when you go to solve the other equation, you're going to, wherever you see an S, you will put 116 minus 3t. Okay, so the top equation was 13t plus 4s, but s, we just figured out, is 116 minus 3t. And then we write the rest of the equation equals 487. And then we do the distributive property. We need to know what 116 times 4 is. 464. Minus 4 times 3 is 12t equals 487. So we have some like terms here, but it's kind of nice. We have 13t minus 12t. That's just 1t. So we're going to really quickly be able to solve this for how much ties cost. Once we subtract 464 from both sides, you will know how much a tie cost, and you'll be done with a big part of this problem. After you know what t is equal to, which you will really quick, then you can plug that back into one of your equations. You could even plug it back into this one, although you're supposed to use one of the originals just in case you made a mistake somewhere. So we could plug it into this one, 6 times whatever we get for t plus 2s equals 232, and then you finish solving to find out how much suspenders cost. And then pick one other problem to solve after you finish this one, and then you'll be done. Thank you very much and have a wonderful day.